So the question is, so you've got all this convection in the tropics. Why isn't it coming, or what is coming from Antarctica? Is that correct? Right. Yep. Antarctica does play a large factor in our winter weather. Hasn't been able to do much of late because we've got a La Nina and all the weather pressure systems have been pushed southwards. The roaring 40s are normally sitting quite happily over Auckland during August, but they're not here yet. They have to wait a few more weeks. They'll get here, don't worry. And the roaring 40s, we can measure exactly how strong they are with a factor which I call the polar vortex, which is the speed of the wind around Antarctica. When this number is low, it doesn't bother us like where it is now. If that number goes very strongly positive, we get lots of westerlies. If this number goes negative, and if it dies negative, then we actually get a polar outbreak or polar outburst. I'm trying to use the analogy how it was explained to me by Augie Hour. He would say, think of planet Earth, okay? Now, all the air over Antarctica is very cold, so it's almost sort of jellified. It's turned into jelly. It's so cold it's like jelly. And it sits like an inverted bowl over the South Pole, over Antarctica. It spins around being held there by the polar vortex. It doesn't get a chance to get north. However, if the polar vortex weakens and you get a little high come through, which manages to have some southerlies on it, these southerlies winds come from the south. They can act like a shovel and take some of that jelly, break the like a dam, wall of the dam, and let that jelly burst and travel outwards, which means northwards. Might not hit New Zealand, it might hit South America or some other part of the planet, but that's the polar outbreak. Now, we had one last September, and it brought snow, which was settling over places like Wellington and Waikato, and even had a few flakes in Queen Street, which is unusual, but it was caused by a polar outbreak. And we got a nice little program or a way of monitoring or measuring it, which is called by NIWA, called the SAM for short, standing for the Southern Annular Mode. But the Southern Annular Mode basically measures the strength of that polar vortex. So when you're trying to do a seasonal forecast for the next 3 months, you can't just look at the tropics, El Nino, La Nina, but you also got to consider what's happening further out west, the monsoon. What's it doing? You've got to look down south, the polar vortex. What's it doing? Will we have a polar outbreak? And the chances are pretty low at this stage. And the other factor we have to consider is the blocking, the position of the jet streams, which are feeding the movements or the non-movements of the anticyclones across us. So it's not just El Nino, La Nina. Several ingredients have to be put together like a jigsaw before you can come up with a forecast, which is basically follows that original way of the art of writing a weather forecast. In the art, you've got to remember, you've got to add a disclaimer. Put in that otherwise fine. And so when I do a seasonal forecast, I sort of say, well, we expect El Nino to turn up in the atmosphere in the next 3 months, in which case you'll get this, that, and the other thing. But, we always have a but. But the polar vortex does have an opportunity occasionally to make itself apparent. So there you go. Seasonal forecasting is very much a science and an art and a communication. Number of times I've seen the day before the Wahine storm, with everything looking exactly the same. And you know, I've studied that Wahine storm, so I know exactly how it was derived and evolved and how the pattern behaved. So whenever that kind of pattern starts to show itself again, of course you start thinking, oh, this could be a Wahine storm. And I've seen it 10 times and not one of them came out to be like a Wahine. In fact, they're all fizzes. Only the Wahine storm did what the Wahine storm did. So You can start at time zero with something which you've seen in the past, but to try and use analog forecasting, uh, it's a nice system to use. And I must admit, a lot of my America's Cup forecasting was along that way of analog forecasting, because we're dealing with sea breezes most of the time. And the good thing about sea breezes are they are good at following pattern. So if you're just working with your own sailing yacht and you're just heading towards Waiheke on a beautiful sea breezy day, you know that as you approach Waiheke, the breeze is going to swing to the right. It just does it all by itself. It's a pattern, and you can rely on that. But some of the larger patterns which lead to storms are not so reliable. So that's analog forecasting is the technique which you're talking about, and yes, it has got its values, but it does have its limitations, honestly. The question is, why are we not getting as much information from flying over aircraft as we had in the past for the ships at the sea? And I guess the system has evolved that the forecast, the aviation technologies have got to the stage where most of their communications is done by transponder now. They are reporting the wind and many other facets of their travel every minute by transponder to their home ground controls. And that's being evolved all the time. But none of that data is getting to anywhere else except for only along their own channels. When I was over in Barcelona, we were waiting for the sea breeze to kick in. And according to the AP flag, it looks as though they were thinking of perhaps cancelling for the day. And the sailors are saying, well, I think that's another day wasted. I said, no. Look at that aircraft. It's heading for Barcelona Airport. They've changed the runway. It's coming in from the north now. That means the breeze has reached the Barcelona Airport. The sea breeze is there. And it's only 5 kilometres away. If we wait an hour, the breeze will get here. Sure enough, it worked. So if you can just watch the aircraft as they fly into Auckland, you'll at least be able to work out what the wind is doing at Auckland Airport. How's that sound? And of course, the weather data from Auckland Airport is available on your cell phone or on your. It's not available on the Coast Guard nowcasting, but it is available on cell phone and various other ways. You can get it. And predictwind.com is a nice little iPhone or Android app which will show you what the wind is doing at Auckland Airport and gives you a graph of it for the last 24 hours. So the data is sort of slowly coming back into the coastal areas. But certainly, if you keep an eye on those aircraft, they will give you a little bit of a hint of what's going on up there. You've heard that I've been reading about the tropical convergence zone has been expanding, and they wanted to know if climate change is having an impact upon the weather zones on the planet. Is that right? Oh, the Albany doctor. Yes, right. Fremantle doctor, but yeah, the Albany doctor. They've got a Kalgoorlie doctor as well, but he doesn't arrive until 3 a.m. Pretty late. Right, so yes, okay, climate change question. In my life as a meteorologist, I've noticed various changes in the weather patterns. You can see it in the weather maps. For the first 20 years of my life, I used to draw all of the weather maps by hand. We never used the 1040 hectopascal isobar. And nowadays, pretty well once a month, certainly once every couple of months, along comes an anticyclone with a 1040 isobar on it. So the highs seem to be getting higher. The lows are not getting any lower than what they used to, but even having higher highs than what they were in the past does mean that there is a visible impact in today's weather map from the change in climate over my lifetime anyway, 40 years or so forecasting. And as for whether it's actually affecting the convergence zones in the tropical oceans, whether they're getting wider or not, that I don't know. I'd have to read more about that. It's a sort of an area which would require more study. But yes, indeed, climate change is starting to have an impact on our daily weather